Welcome back, everyone. I'm absolutely thrilled you're tuning into this explainer because today we are unpacking something truly groundbreaking. We're looking at a brand new, literally just dropped March 2026 research paper that is completely revolutionizing how artificial intelligence conducts scientific research. It's a comprehensive overview of a system that is poised to entirely change the face of end-to-end scientific discovery. To really grasp why this paper is so incredibly significant, I want you to picture something for a second. Imagine an AI that is exceptionally brilliant. We're talking an AI that can conduct complete end-to-end scientific discovery, right? Reading literature, formulating hypotheses, even writing the raw code to run the experiments. But there's a catch. It suffers from severe amnesia. It completely forgets every single failed experiment it has ever run. Every time it starts a new task, it's starting from zero, totally blind to its past mistakes. I mean, think about how frustrating and wildly inefficient that would be. Well, that amnesia is exactly what researchers are finally trying to cure. Here is how we're going to break this down today. First, the problem with static AI. Second, introducing the EvoScientist framework. Third, 3 specialized AI agents. Fourth, the power of persistent memory. And lastly, beating state-of-the-art systems. All right, let's dive into section 1, the problem with static AI, brilliant but forgetful. So the increasing adoption of large language models has basically allowed AI systems to step right into the role of the scientist. They can coordinate all these specialized roles like generating ideas and executing experiments. But there is a massive bottleneck. Most state-of-the-art AI scientist systems right now rely on static, hand-designed pipelines. Now, what does that actually mean? Well, it means they do not adapt. They don't grow or evolve based on their accumulated interaction histories. They are incredibly capable in the moment, for sure, but they're essentially frozen in time. And here are the very real, very frustrating consequences of that static amnesia. Because they can't remember what they did yesterday, or honestly even an hour ago, these systems end up wasting immense amounts of computational time and resources. They overlook highly promising research directions. They repeatedly run the exact same failed experiments, literally making the identical coding errors over and over again. And they stubbornly pursue ideas that have already proven to be completely infeasible. It's just a huge roadblock for true autonomous scientific discovery. Which brings us to section 2, introducing the EvoScientist framework, the evolutionary leap. To finally fix this giant memory hole, the researchers built EvoScientist. They define it specifically in the paper as an evolving multi-agent AI scientist framework. Now, the absolutely crucial words here are evolving and multi-agent. Instead of just one single static program trying to do everything and immediately forgetting it all, this is a highly dynamic system. It's specifically designed to continuously improve its own research strategies. Think of it as a massive paradigm shift. The old way was just static pipelines, trapped in this endless, frustrating loop of repeating failed experiments and chasing dead ends. But the EvoScientist way? It actually uses persistent memory and self-evolution to break out of that loop. It learns from its own interaction history to continuously improve. It's basically the difference between hitting a brick wall repeatedly versus actually remembering the wall is there and, building a ladder to climb over it. Moving right along to section 3, 3 specialized AI agents, the collaborative research team. To pull all of this off, the system needs some serious structure. In fact, it operates a lot like a multi-talented startup team. EvoScientist is made up of 3 highly specialized agents working closely together. First up is the researcher agent, or RA. This agent acts as the primary theoretician. Its entire job is scientific idea generation. Next is the engineer agent, the EA. This is your coder and technician, responsible for actually implementing the experiments and executing the raw code. And finally, we have the evolution manager agent, the EMA. Now, this agent is the real secret sauce of the whole shebang. Its job is to look at what the researcher and engineer just did, analyze the prior interactions, and then distill those insights into reusable knowledge. Okay, section 4, the power of persistent memory, the brain of the system. This brings us to the absolute superpower of EvoScientist. How do these agents actually store and use that reusable knowledge? The answer lies in 2 distinct persistent memory modules, essentially giving the framework a dual hemisphere brain. On one side, we have the ideation memory. This is purely for brainstorming. It actively summarizes feasible research directions from top-ranked ideas while strictly recording the unsuccessful directions so the researcher agent doesn't accidentally suggest them again. On the other side is the experimentation memory. This is the highly technical side. It captures effective data processing steps, model training strategies derived from code search trajectories, and basically the absolute best performing implementations. And here is why this dual memory system is such a total game changer. By allowing the researcher agent and the engineer agent to seamlessly retrieve these relevant prior strategies, the AI actively gets smarter with every single run. The idea quality improves because it remembers what theoretically works. The code execution success rates absolutely skyrocket because the engineer agent remembers the exact data processing and training strategies that successfully bypassed errors in the past. It is literal self-evolution happening in real time. And that leads us perfectly into Section 5, beating state-of-the-art systems, the results. 7. You're going to want to remember that number. The researchers conducted some incredibly rigorous experiments and found that EvoScientist successfully outperformed 7 different state-of-the-art systems. And we're talking about both top-tier open source and commercial systems here. It didn't just beat them by some tiny, narrow margin either. It demonstrated a fundamental superiority in how it approaches scientific tasks. When it was evaluated using both automatic metrics and actual human evaluation, EvoScientist completely dominated across the board. In scientific idea generation, it achieved significantly higher novelty. The ideas weren't just new, they had far greater feasibility, meaning they could actually be tested in the real world. They had improved relevance to the core scientific problems and way better clarity in how they were articulated. Furthermore, thanks to that multi-agent evolution we just talked about, it substantially improved code execution success rates compared to all those static pipelines. Which brings us right to the ultimate conclusion, drawn directly from the paper's abstract. The authors state that these results are, quote, demonstrating persistent memory's effectiveness for end-to-end scientific discovery. They've definitively proven that giving AI the ability to remember, to reflect, and to genuinely evolve is not just some neat little feature. It is the defining requirement for the next generation of autonomous scientific research. So I really want to leave you with a massive question as we wrap up today's explainer. We've just seen how giving an AI persistent memory allows it to stop repeating mistakes and start accumulating compounding knowledge. If systems like EvoScientist can continuously evolve their own research strategies, working flawlessly as a unified team of researchers and engineers, what world-changing scientific breakthrough will it discover next? The potential here is just absolutely staggering. Thanks so much for focusing in with me today, and I'll catch you on the next explainer.